Yeah, yes, is audio fine now? So those who have joined me for this session, do not forget to like and share the session, and also subscribe our YouTube channel if you have not done yet. Okay. So good evening and welcome to Resultant AJ YouTube channel. Today we are going to practice question on thermodynamics and application, which is basically we are going to practice questions on IC engine, refrigeration and power plant. Thermodynamics we have already completed, fluid mechanics we have completed yesterday, and today we are going to take the subjects of thermodynamics and applications. Audio working now? Yeah, audio is fine, please tell me. Good evening, MS, Shiv Mohan, Anand Prateek, Mohit and Mohammad Nawaz. Good evening, welcome to a session. Those who have joined me for this particular session, and if you don't know about me, let me tell you, let me just give you a short description about myself. My name is Vikas Sir and I'm a faculty of mechanical engineering. I have over 7-year teaching experience. The subjects that I generally teach are fluid mechanics and thermodynamics, applied thermodynamics subject. Okay, and these are my qualification. I have mentored more than lakhs of students for these examinations. My dear students, as you know that tomorrow we'll be celebrating our 78th Independence Day. So we are providing you from today onwards only, we are providing you 55% discount on all our courses, whether you are preparing for GATE, engineering services or RRB JE. On all our courses, we are providing 55% discount. You just have to use this coupon code India55. If you use this India55 code, then you will get 55% flat discount on our courses for RRB JE, GATE or ESE. Okay. My dear students, those who are from mechanical background, I want to tell you that in our courses of RRB JE, these will be the 4 faculty teaching you subjects of mechanical engineering, and we have basically 3 types of courses currently we have for RRB JE preparation. CBT1 batch called focus batch, CBT2 called aim batch, and combined for CBT1 CBT2 called mission batch. Now those who are interested only for CBT1, you can see the price, MRP price and offer price right now. So please have a look over the offer price, because this is valid only for limited period of time. Okay. And on this number you can just call to get the information how you can purchase our course, and you can also mail us here. Okay, so these are the information about aim batch, mission batch. Okay, let's come to question number 1. I hope all of you are getting the clear audio and video now and you are not having an issue. Yes, please let me know if audio and video is fine or not. Is audio video fine? Please tell me, everyone. Okay, first question is, axial flow compressor has the following advantage over centrifugal compressor. What is the advantage of axial flow compressor over centrifugal? Well, both axial and centrifugal are dynamic types of compressor. Dynamic compressors, and the dynamic compressor classification, basically what happens is, in these compressor a conversion of kinetic energy into pressure energy take place. And that is how the pressure is increased in these types of compression. Okay, so firstly we increase the kinetic energy of the air and then we convert that into pressure energy. Well, axial compressor has large air handling ability per unit frontal area, because if you compare the front area of axial flow compressor, it is less as compared to centrifugal compressor, and it is having large air handling ability means it can give you more discharge with respect to the frontal area. It has small frontal area. Okay, high pressure ratio is wrong, because axial compressor has small pressure ratio. It has got pressure ratio of 1.2 to 1.4. That is why we require multi-staging for axial flow compressor. Centrifugal compressor has more pressure ratio compared to axial, which is about 3 to 4. Okay, next. How is the air compressed in a double acting compressor? How do you compress the air in a double acting compressor? See, the meaning of double acting compressor is that air will not be compressed in one cylinder, but it will be compressed in a single cylinder on both sides of the piston. air will be compressed in a single cylinder. This is a single cylinder, but if this is your piston, then on both sides of the piston the air will be compressed. Okay, so that is the advantage of double acting compression. Not in just one cylinder, but on both sides of the single cylinder. In a two-stage reciprocating compressor, suction pressure is 1.5 bar and delivery pressure is 54 bar with a perfect intercooler. In both stages, if both stages follow same polytropic process, then intermediate pressure will be equal to. Hello Ramjeevan, good evening. Hello Prisma, good evening. Welcome to a session. So we are having a two-stage compression process, and two-stage compression process for first stage. In the beginning of the first stage, the pressure is 1.5 bar. You have to find the intermediate pressure, which is P2, and the final pressure, which is P3. Second stage pressure is final pressure is given to you as 54 bar. Okay, 1, 2, 3. So this will be the pressure volume diagram. All right. Now you know that for perfect intercooling, you must have read this formula. For perfect intercooling in two-stage compressor, the pressure ratio, there are some important points. That is, when perfect intercooling takes place, then pressure ratio in each stage becomes equal. Okay, so based on this concept, you can get P2 will be equal to intermediate pressure in the second stage will be equal to geometric mean of suction pressure of the first stage and delivery pressure of the second stage. So when you put these values here, you will get 1.5 into 54. That will come out to be 81, and square root of 81 will be equal to 9 bar. So the answer will come out to be 9 bar. Clear? Next, which of the following air compressor is generally used in gas turbine? Which of the following air compressor is generally used in the gas turbine? Well, in the gas turbine, see, we can use both the compressor, but generally, when we say generally, that means we are talking about axial flow compressor. Okay, there is also some confusion in some students' mind that, sir, why not radial flow compressor? Radial blower is not correct, but it is radial flow compressor. But it is generally axial flow compressor, which we generally use for gas turbines. Okay. And this was also previous year question of RRB JE. Okay. And this is also previous year question of RRB JE asked in RRB Allahabad, which the paper which was provided in RRB Allahabad zone on 9th of September 2012. The compressor used in a gas turbine are typically of which type? Typically of which type? Axial flow compressor. So typically or generally we use axial flow compressor in the gas turbine. Clear? So I am just showing you how the questions, some of the questions are repeated like this. What is the unsteady to and fro motion of the fluid that causes pulsation in the engine compressor known as? Unsteady to and fro. See, what is the meaning of to and fro? To means forward, motion, and fro means, let's say, backward. Okay, so to and fro motion means like this. Once you go like this, then you go like this. This is to and fro motion, like a pendulum. So this is basically to and fro motion, nothing but reversal of the flow. That is reversal of flow. A reversal of the flow, you know that, you all know this. Reversal of flow we study, that is called as surging, or it is also called backflow, right? Why it take place? There is some issues in the compressor, but that is called surging. That is backflow take place in the compressor. That is, and it also creates some pulsation. Pulsation means some sound in the compressor, pulsating sound in the compressor. Okay. Maximum work is done in compressing the air when the compression is. When we say compression, that means there are many ways we can compress the air, right? There are many ways by which we can and you must be thinking, sir, only why are we seeing only compressor questions? The reason is, if you see RRB JE syllabus, then in RRB JE syllabus, you will find only compressor from power plant topic. Okay. So from power plant subject, you will only find compressor topic. Okay, so that is why we are mostly seeing the compressor questions. So there can be many ways by which you can compress the air, right? Either you can do the compression by isothermal process, or by polytropic, or by adiabatic process. In all these three ways you can do the compression. So if, let's say, if you are doing constant temperature compression, or you are doing polytropic compression, or you are doing adiabatic compression. So in this question they are saying maximum work is done in compression. Maximum work means which consumes the maximum work, because it is work input. So maximum work is consumed in which compression? Least work input will be in the this will be the least work input. The area under PV diagram, least work input will be for isothermal process, and maximum work input will be for adiabatic process. Okay, maximum work input will be for adiabatic. So the right answer will be adiabatic, option B. Clear? Least work input, if it is asked in the exam, then you have to answer isothermal, and maximum work input will be adiabatic. An ideal air compression cycle with clearance on PV diagram can be represented by. What is the meaning of with clearance? So when we study the reciprocating compressor, we can study two conditions of reciprocating compression. One is ideal condition, one is actual condition. Okay, in the ideal condition you can study it without clearance volume, when we don't consider clearance volume, although that is the ideal case, because in actual case we have to consider the clearance volume. So without clearance volume is one case, okay, when we don't consider the clearance volume, and one is when we consider the clearance volume in the reciprocating compression. Okay, when we consider the clearance volume, it is called actual compression, actual case. When we don't, then it is called ideal case. So here, my friends, we are talking about, please launch Hindi batch. We will surely launch Hindi batch, but considering the demand from the students, we will launch. Okay, but initially we have more demand for English batch, and so that's why we have launched English batches. So the right answer will be option B, 2 adiabatic and 2 isobaric. When we say with clearance, then these are the process. Okay, and when we say without clearance, then these will be the process. On the PV diagram, without clearance. In ideal situation, this is how the process will be represented. In the actual condition, the process will be 2 adiabatic and 2 isobaric. The vertical and uniformly spaced lines on the cyclomatic chart indicate. And one more beauty of solving the previous year question is, you will understand that what are the areas from where the questions are being asked in the exam. Okay, you will understand that, right? We can understand the important topics, the important questions. Like from power plant subject, you can see compressor. Mostly questions are from compressor. From REC, you will find this is the question, right? Cyclomatic chart. So that means cyclomatic chart is important. The vertical on the cyclomatic chart, the vertical and uniformly spaced lines. So this is cyclomatic chart. On cyclomatic chart, the vertical and uniform spacing line are called as constant dry bulb temperature line. Constant dry bulb temperature lines. These are dry bulb temperature. Next, a 10-ton refrigeration system consumes 10 kilowatt of electrical energy. Its coefficient of performance will be. So the refrigeration system that we have is of 10-ton refrigeration. That means how much amount of cooling we are going to get, how much amount of cooling effect. The cooling load of this refrigeration system is equal to 10 tons. Now, what is the value of 10 tons? What is the value of 1 ton? Sorry, 1 ton is equal to 3.5 kilowatt. So, if you multiply it with 3.5, you will get 35 kilowatt. That is total. This is the total amount of cooling that we can get from the refrigeration system. And what is the meaning of consuming this much amount of electrical energy? So this is nothing but the power input. This is the power input. So you know the power input, you know the cooling load, then COP is equal to the cooling load that your refrigeration system can withdraw, that can provide, over power input divided by power input. So when we put these values here, you will get 35 by 10 and the answer will come out to be 3.5. Most of you have given the right answer. Very good. Next, normally the following condenser is used in the big refrigeration system of air conditioning plants. So when we say air conditioning and big air refrigeration system, that is large refrigeration system and large central air conditioning. Which type of condenser will be used? Shell and tube condenser. Shell and tube condenser have a large cooling capacity, right? From 2 tons to 1000 ton cooling you can achieve from these types of condensers. Now, obviously they are not going to provide you cooling, but what is the function of condenser? Condenser rejects the heat. So when condenser will reject the heat, this much amount of heat, then after getting rejected, the refrigerant will become more cold, right? And then when it will go through throttling device, it will become more cold and it will provide more cooling effect, right? So that is why we need this kind of condenser. Okay, shell and tube condenser, not evaporative condenser. Evaporative condenser is used in the ice plant. It is used in the ice making plant. Okay, especially for ice making plants. In our refrigeration cycle, the flow of the refrigerant is controlled by the flow of refrigerant. So if you see a refrigeration cycle, then the refrigerant will flow through many components and it will work in a cycle. Firstly, it will go into a compressor. When it will go through suction process, it will enter compressor and it will undergo adiabatic compression, reversible adiabatic compression from 1 to 2. And after getting compressed, the heat will be rejected with the help of a condenser, right? It will reject the heat at constant pressure. And then what will happen? Then throttling process will take place. If you see this on temperature entropy diagram, then what happens? Throttling process takes place. Now, throttling device that we use in the refrigeration cycle is called capillary tube. And this device is also doing what? It is also controlling the flow of refrigerant. A throttling device is nothing but an expansion valve. It is an expansion device. So expansion valve will control the flow of the refrigerant. Where? To the evaporator. So basically the evaporator which is providing the cooling, so that evaporator is receiving the refrigerant, chilled refrigerant, after it passes through throttling device or any expansion device, right? It can be any expansion device, whether it is capillary tube. See, it can be capillary tube, which is throttling device. It can be thermostatic expansion valve. It can be automatic expansion valve. It can be automatic expansion valve. It can be float valve. It can be float valve, depending on which type of evaporator is used. Okay, there are different types of expansion devices, but the function of the expansion device is to control the flow of the refrigerant and also reduce the pressure of the refrigerant from condenser pressure to the evaporator pressure, right? In a vapor compression cycle, the refrigerant before entering the expansion device is, before entering the expansion device, so the refrigerant enters the expansion device at what condition? After the refrigerant has passed through the condenser, then it enters the expansion device. So let us draw again the temperature entropy diagram. So if this is your entry to expansion, this is the entry to expansion valve or expansion device, remember? So at this particular point where the entry takes place, what we have at this point, we have a liquid, right? And that liquid is basically high pressure liquid. It is a high pressure liquid, high pressure saturated liquid. Clear to everyone? Because just before this we have a condenser, and what is the function of condenser? The function of condenser is to condense the vapor, the superheated vapor that has being released from compressor, They have been compressed by compressor, and this is what the condenser will receive. Condenser will reject the heat of the superheated vapor and convert that into liquid. Now this liquid is a high pressure liquid. It is not low pressure liquid. It is a high pressure liquid. Remember this, right? Because if you see, again, I want to show you one diagram, which is pressure enthalpy diagram. The whole vapor compression cycle works between two pressure, high and low pressure, right? And the component which, with the help of compressor, the low pressure vapor gets compressed and its pressure is increased. But with the help of expansion device, with the help of expansion valve, the high pressure liquid pressure is decreased and it reaches the evaporative pressure, right? So this is the condenser. Condenser is at high pressure and evaporator is at low pressure. Okay, are you getting this? So at the entry of the compressor, we have, at the point number 1, we have saturated vapor. We have saturated vapor at point number 1, which is also the suction to the compressor. At the exit of compressor, point number 2, we have superheated vapor. Okay, we have superheated vapor. At the exit of the condenser here at point number 3, we have saturated liquid. Clear? We have saturated liquid. And at this particular point, point number 4, we have wet vapor. So this is very, very important, my dear students. Clear to everyone? Next, Bell-Coleman cycle is applicable to. Bell-Coleman cycle, known, you know it by many names. It is also called reverse Brayton cycle, right? It is also called reverse Brayton cycle. It is also called reverse Joule cycle, or it is also called a cycle that is used for air refrigeration system. Okay, next question. A refrigeration plant operates in reverse Carnot engine. The temperature maintained is -10 degrees Celsius. Okay, and the heat is transferred at the rate of 10 kilowatt. The heat is transferred from the cycle to the atmosphere at temperature 25. What is the power required to drive the plant? So basically what is being given in the question here, that your refrigeration system is rejecting the heat at 25 degrees Celsius and the temperature it is trying to maintain here is -10 degrees Celsius, temperature being maintained, low temperature, that is 263 Kelvin, this is 298 Kelvin. Okay, high temperature. And they are basically asking what is the power input that this refrigeration system will need, and the heat is transferred. Heat is transferred at what rate? 10 kilowatt. 10 kilowatt. This is given. It's a very simple question because it works on reverse Carnot cycle. Firstly, we'll find the COP in terms of temperature, that is lower temperature divided by higher minus lower temperature, which will be 263 divided by 35. If you solve it, you will get 1 COP. Then after putting this COP in this particular formula, which is the desired effect, which is 10 kilowatt over power input, you will get the power input. Clear? Just solve this question and tell me what will be the answer. And also you can use the calculator, because in your exam of CBT2, whether you are preparing for SSC JE or RRB JE, calculator is allowed. So don't feel shy to use calculator. Okay, you can use calculator now. Okay, yeah. Okay, so if you solve it, you will get power input is equal to 1.33 kilowatt. Clear? Is it clear to all of you? Now, those students who are from mechanical background, you must be thinking, sir, we have to prepare for RRB JE. So for that, CBT1 is only important. But let me tell you that any preparation, if you want to crack any exam, especially JEE level, you need to be good in both technical and non-technical. And by meaning being good is that you have to be always ready. It's not that when that CBT 1 will be over, then you'll study for CBT 2 and then you'll study for technical. Okay, so those who are coming to the session, those who are daily attending the session, even after knowing that CBT 2 will take place maybe in the month of November of RRB JE, but still those who are preparing before, like daily coming to the classes, attending the sessions, it's very good, great motivation. And if you have not liked or shared the session, then please do that. The door of a running refrigerator inside a room was left open, which is the following statement is correct. The door of a running refrigerator. So let's say we have a refrigerator, we have a room here, and in that particular room we have kept a refrigerator, big room, and big room you have kept a refrigerator. Obviously refrigerator is a food preservator that is used basically to keep your all the edible things like food, vegetables, fruits, or any kind of your things in the refrigerator as a food preservator. So this is your refrigerator, right? But by mistake, what you have done, you have left the refrigerator door open. That is not good actually. So what will be the after effect? After effect is that the room will gradually get warmed up. Okay. Basically what the first question is, you need to firstly understand how the refrigerator functions. See, refrigerator, what does refrigerator does? If the door is closed, then what it will do? Whatever food items you have kept in the refrigerator, for those food items, it will absorb the heat. It will take the heat. It will take the heat from those food items and it will reject the heat to the room. Okay, the condenser kept at the back. So this is your room. Now what will happen if you open the door of the refrigerator? Then what will happen? Although the refrigerator, the function of the refrigerator is limited only inside the cabinet of the refrigerator. But when you open it, then it will try to take the heat from the entire room. It will try to take the heat from the entire room, right? And also it will reject more heat to the entire room. Is it clear or not? And my dear students, if you remember the concept of a refrigerator, in case of refrigerator, heat rejected is always, it will be more than the heat absorbed. So it is because the heat rejected is more than the heat supplied. Because it is taking more heat, it will reject more heat. So the room will ultimately get warm. It will get warmer. Okay. A simple saturated refrigeration cycle has following state points. Enthalpy after the compression is 425, after throttling is 125, before compression is this. COP you have to find. Now, I have told you a trick to solve this question of a simple saturated refrigeration cycle, also called VCRS cycle, vapor compression refrigeration cycle. And I told you the concept, that is whenever you find a numerical related to vapor compression, what you need to do is you need to just put the values here. Okay. It is desired effect. Formula will be same, desired effect divided by work input. And you know the relation between the enthalpy, that is H2 is more than H1 and H1 is greater than H3 equal to H4. What is the largest value of enthalpy? That is 425, that becomes H2. Then mid one will be 375, the smallest is 125. Just put the values here in this formula, you will get 375 minus 125 divided by 425 minus 375. Solve it, get the answer, tell me the answer. Yes? Clear? Tell me everyone. Okay, the answer will come out to be 5. Next, in a vapor compression refrigeration cycle, heat is rejected by the refrigerant in. Now, which of the following is the component which rejects the heat? In a vapor compression cycle, The component which rejects the heat is condenser, which absorbs the heat is evaporator. So this is a component which rejects the heat. Next, condensing temperature in a refrigerator is the temperature. What do you mean by condensing temperature? I have drawn this temperature entropy diagram 2 times in this session. So when we say condensing temperature, that means we are talking about that temperature at which condensation takes place. So firstly, in the compressor, the compression will take place where the saturated vapor will get compressed by the compressor and it will become superheated vapor. And that superheated, when it will go into the condenser, then that superheated vapor gets converted to saturated liquid. So the condensing temperature, the temperature at which refrigerant becomes, yes, this is a condensing temperature, the condenser temperature. It is that temperature at which it becomes liquid or has become liquid. Okay, so the right answer is option C. Okay, because when we say condensing temperature, that is the temperature at which condensation takes place. That is a constant temperature at which condensation takes place. This is a constant temperature at which condensation will take place, saturation temperature. Waste heat can be effectively used in which of the following refrigeration system? Waste heat, basically we have different types of refrigeration system: vortex tube refrigeration system, vortex tube refrigeration system. It is also basically called as air refrigeration system. It is also type of a air refrigeration system. But this refrigeration system provides both hot and cold air. Both hot and cold air are simultaneously provided. So you get both hot air and cold air from the system. Okay, it can be used for heating and cooling both. Vortex tube. Waste heat. When we say waste heat, then we are talking about vapor absorption, because vapor absorption is a heat operated system. It is a heat operated refrigeration system. And heat is basically low grade energy. Okay, so vapor absorption is a heat operated, while vapor compression, air refrigeration, vortex tube, they all takes work input from compressor. Okay, so it takes work input from a compressor. The working fluid is also compressed air. So it uses compressor, it uses compressor, it uses compressor. Compressor means work input. They take work input. Okay, but this is a heat operated system. Next, the purpose of installing a flash chamber in the refrigeration circuit is to. Why do we need a flash chamber in the refrigeration circuit? Yes. What is the main purpose? Improves overall heat transfer coefficient, reducing the pressure losses through the evaporator and reducing the size of the evaporator by avoiding vapors going to the evaporator. See, this is something that I have taught you, that the main purpose is to reduce the size of the evaporator. We don't require a large size evaporator, but apart from this effect, if we use a flash chamber, the purpose of the flash chamber is it will separate the flash chamber is basically, it consists of these kinds of plates. From these plates, when saturated, when wet vapor from the expansion device enters this flash chamber, then what happens? On the top of the flash chamber, what happens? Saturated vapors get separated, and the bottom, what is being collected the bottom? At the bottom we get saturated liquid. Okay, so ideally the answer should be option C, but if you consider the other options, the purpose of installing a flash chamber in a refrigeration circuit is not just to reduce the size of the evaporator, it overall improves the heat transfer coefficient and pressure losses. So option D will be the right answer in this case. If option D would have not been there, if all the other options which are mentioned here would have not been there, then definitely option C would have been the answer. Okay, but since It contains option D, which is all of the above, and the other two options are also somewhat are achieved by using flash chamber. When we use flash chamber, we also achieve improvement in the heat transfer coefficient. We get better heat transfer rate and also reduce pressure loss from expansion from condenser to evaporator. In aqua ammonia and lithium bromide system, the refrigerants are respectively. When we say aqua ammonia and lithium bromide system, in aqua ammonia, aqua means stands for water, okay, and water is basically an absorbent, while in lithium bromide system, water is the refrigerant, okay, and this becomes the absorbent. The concept is the refrigerant has generally low boiling point, okay, refrigerant should have low boiling point. So this is lithium bromide has boiling point of 1265 degrees Celsius boiling point, okay, while water has boiling point normal at normal pressure is 100 degrees Celsius, okay, BP boiling point. In case of ammonia, the boiling point is minus 33.3 degrees Celsius. Water has a boiling point of 100 degrees Celsius. So main criteria for selecting the refrigerant, which will be the refrigerant, ammonia will be the refrigerant here and water will be the refrigerant here. So answer will be ammonia and water, okay. Criteria is refrigerant should have low boiling point. The whichever will have low boiling point will be refrigerant, okay. So out of if you see both the system, you will find in one of the system ammonia has low boiling point, so it is definitely going to be the refrigerant, and here the water has low boiling point if you compare with lithium bromide, so water will be the refrigerant for lithium bromide system. Now let's solve the questions of IC engine, okay. In a 4-stroke cycle, the minimum temperature inside the engine cylinder occurs at the, in any 4-stroke cycle, what are the main 4 processes? Firstly, the suction take place, then compression take place, compression stroke. Then compression stroke is followed by the expansion stroke, which is also called the power stroke, and the power stroke is further followed by exhaust stroke, where exhaust take place. Now, tell me, where will be the minimum temperature? Think about it. The minimum temperature will be at the beginning of suction, because when we say suction, that means for maintaining suction inside, when you want to do the suction, let's say you want to take the air, you want to suck the air, then you need to create low pressure inside your body, because so then only outside air will come inside your body, right? So low pressure means low temperature. That means beginning of suction stroke, the temperature will be least or minimum temperature, okay, in the beginning of suction stroke. A certain engine produces 10 kilowatt indicated power. Its mechanical efficiency is 70%. Then the frictional power is. So whenever this kind of questions come, so you know 2 types of formula of engine. One is mechanical power is equal to brake power by indicate power, and one is friction power is equal to indicate power minus brake power. By using these 2 formula, you can solve this question. But I have also told you one trick, that when you know the indicate power and mechanical efficiency, right, you can directly use this particular concept, that friction power is equal to indicate power divided by 1 minus mechanical efficiency, okay. This is the concept. Or just a second, let me just make this formula more clear to you. How you get this formula? So when mechanical efficiency is 0.7, 70%, mechanical efficiency is equal to brake power. Now brake power will be equal to indicate power minus friction power divided by indicate power, which you will get 1 minus friction power by indicate power. right? So friction power by indicate power will be equal to 1 minus mechanical efficiency. So we can get friction power is equal to 1 minus mechanical efficiency into indicate power. You just remember this formula, 1 minus this formula. Friction power is equal to 1 minus mechanical efficiency into indicate power 1 minus 0.7. So in your exam you can save your time. You can save your time and you don't have to do this kind of calculation. Just remember, if indicate power is given to you, mechanical efficiency is given to you, just 1 minus mechanical efficiency into indicate power gives you friction power. Okay. Petrol and diesel engines of the automobile are, if you see your IC engine, RRB JE syllabus or SSC JE syllabus, you will find some questions from automobile also. Most of the automobile are reciprocating engine. That is, basically they will be consisting of a piston cylinder device where a piston will be doing a reciprocating motion inside the cylinder. Okay, whether it is horizontal engine or it is a vertical engine, but most of the petrol diesel engine are basically reciprocating engine where a piston will be doing reciprocating motion inside a cylinder. Okay, which of the following item is made of aluminum alloy? So all are the piston rings, connecting rod, piston and crankshaft. These all are parts of the engine, right? They all are basically parts of engine cylinder, right? They all are inside the engine cylinder. Well, engine cylinder is basically made of cast iron. You all know that. That is made of cast iron. But piston rings, connecting rod, piston is generally made of aluminum alloy. Okay, so the right answer for this question will be piston. Clear? Next question will be, if the temperature of the intake air in an IC engine is lowered, its efficiency will. Now you know that if the intake air temperature, inlet air temperature is lowered, what will happen? You know that density of the air is inversely proportional to temperature of the air. So if temperature is lowered, the density of the air will increase, and density of the air is equal to mass per unit volume. Volume of the engine is same, right? If same volume in the same volume of the engine, if the density is increased, the mass of the charge will increase. More mass enters the engine. That means in the same engine, if more mass will enter, then what will happen? You can get more volumetric efficiency, and if the volumetric efficiency is more, then the thermal efficiency is also more. So the right answer is, if the intake temperature is decrease, then efficiency will increase. The two-stroke cycle engine has, so two-stroke cycle or two-stroke cycle engine has, basically they do not contain valve. Valve is not present. Valve is basically part of four-stroke engine. So when we say valve, it is not something which is related to two-stroke engine, it is related to four-stroke engine. Now in two-stroke engine, what we have got ports, and these ports are covered. Covered means closed. Uncovered means open. These ports are open and closed by piston during charging and exhausting. So the correct answer will be option C. Okay. In the magneto-ignition system, as the engine speed will increase, ignition system, when we say engine ignition system, so battery ignition system and magneto ignition system, when we study spark ignition in the petrol engine, so how the spark is ignited, then we can do the spark ignition either through battery ignition system or we can do it through magneto ignition system. Okay, the required voltage is produced between the spark plug gap, and because of that the spark is created. But as the engine speed increases, the value of the current will increase. Okay, remember this. The function of a crosshead is to guide the motion of the dash and to prevent it from bending. Just a second. Yes. Okay. Yes, just a second. Yeah. Function of a crosshead is to guide the piston rod, guide the motion of the piston rod and to prevent it from bending. So these basically you will find these kind of component in the case of steam engine. So when you study the steam engine, you will find this crosshead, piston rod, these components. Detonation is said to take place in the engine when? When does detonation take place in the engine? Guys, if you have not liked and shared the session, then please do not forget to do that. Detonation is something which take place in the petrol engine also and in diesel engine also. In both the engine, detonation take place, although the reason for detonation are different in both petrol diesel engine. So when we say petrol engine, it is called pre-ignition. Pre-ignition of charge causes detonation in the petrol engine, and in petrol engine we have also called knocking, which is not detonation, of course. It is due to auto ignition. There are two types of theories. One is called auto ignition theory, which basically causes knocking in the petrol engine, and one is called pre-ignition theory, pre-ignition of the charge without spark, that is basically responsible for detonation in the petrol engine. While in diesel engine, sudden acceleration is imparted to the engine. Sudden acceleration is imparted to the engine. It is not asking what is being caused by detonation. It is asking, it is said to take place in the engine. When does detonation take place? It is the effect of detonation. Temperature rises too high, high pressure waves are set up, combustion of fuel takes place without spark provided to it. So based on the options given, only option D is the correct answer, because in petrol engine definitely detonation takes place due to pre-ignition of the charge without spark. Okay, due to repeated knocking, pre-ignition of the charge without spark causes detonation in the petrol engine, while in diesel engine the reason for detonation is different. Okay, what will the effect on thermal efficiency of the diesel cycle, and what is the reason for diesel engine detonation? The reason is delay in ignition of the charge is large. Too much delay in the ignition, that is what causes the detonation in the diesel engine. So in the diesel cycle, if you see, the efficiency of the diesel cycle depends on two important factors. One is the compression ratio and one is the cutoff ratio. Remember the formula for efficiency of the diesel cycle. Now the effect on the thermal efficiency diesel cycle is the compression ratio is fixed. Now we fix the compression ratio and we increase the cutoff ratio. When we increase the cutoff ratio, efficiency of diesel cycle will decrease. So it will decrease. Clear? Is it clear to all of you? Please tell me. Next. Now, if you fix the cutoff ratio, if cutoff ratio is fixed and compression ratio is increased, the efficiency of DL cycle is going to increase. Okay, so this is important. Please remember this thing, that compression ratio has a direct relation with the efficiency and cutoff ratio has an indirect relation with the efficiency. In order to prevent the formation of the carbon on the injector where we use injector, in the diesel engine we use the fuel injector. So if you don't want the carbon to be formed on the injector, then temperature of the nozzle tip should be what? Less than 100, between 100 to 250, or 250 to 300 degrees Celsius. The correct answer is 250 to 300 degrees Celsius, the required temperature at the tip of the nozzle from which the fuel is injected in the diesel engine, if you don't want the formation of the carbon on the fuel injector. In Otto cycle, how does heat addition take place? Tell me, how does heat addition take place in the Otto cycle? The major difference in the three cycle that you study is Otto cycle, diesel cycle and dual cycle. These three cycles are important in context of IC engine. And the major difference between these three cycles is the method of the heat addition. Only this is the major difference between all the three cycles: diesel, Otto and dual, of course. Dual is very simple because it is just a combination of heat addition that you do in the Otto and diesel. Just combine the heat addition. So my friends, in the diesel cycle, the heat addition takes place at constant pressure. In the Otto cycle, the heat is supplied at constant volume. In the dual cycle, the heat is supplied at constant volume and the constant pressure. But if asked in the exam how heat rejection takes place, in all these three cycles, heat rejection takes place at constant volume. In all the three cycles, heat rejection takes place at constant volume. Compression expansion takes place reversible adiabatic. Only difference is the method of heat addition. So asking about Otto cycle, in Otto cycle how the heat addition takes place? It takes place reversibly at constant volume. Why we are saying reversibly at constant volume? Because when we generally study about the Otto cycle, we are talking about air standard Otto cycle, and in air standard Otto cycle, all the processes are internally reversible process. All the processes are internally reversible. So process. That is why the heat addition will also take place reversibly. In a low, so there is some typo mistake here. This is not 400, this is not 300, this is not 100. I should use different color for this. Yeah, this is degree, my dear. This is degree written here, but I think some typo error. No problem. No problem. Let me just correct it. This is 40 degree, 30 degree, 10 degree and 10 degree. Okay. Now remember the concept that I taught you. In any engine, the inlet valve, in any engine, the valve will closes after dead center. It will close after dead center. Before dead center wala answer will be not correct. So this is not correct. Only after, right? But if it is a low speed engine, it will be 10 degree after top dead center. Is it correct? No. Why it is not correct? Because that inlet valve closes at bottom dead center in ideal condition, and in actual condition after bottom dead center. So it is not related to top dead center. Inlet valve opens, the opening of the inlet valve is with respect to top dead center, and the closing of the inlet valve is with respect to bottom dead center. So if it is an actual engine, it will only happen after dead center, so after bottom dead center. Okay. Thermal efficiency of a CI engine is higher than that of petrol engine due to. Thermal efficiency of diesel engine is higher than that of petrol engine. Why? Because of higher compression ratio. It is having more compression ratio. An engine has a clearance volume of 100 and a sept volume of 800. The compression ratio will be. What is the formula for compression ratio? It is total volume divided by clearance volume. Total volume is basically sum of sept volume plus clearance volume divided by clearance volume, or it is equal to 1 plus sept volume divided by clearance volume. Just put the values, you will get compression ratio is 1 plus 800 divided by 100, you will get 9. It will be 9:1. Clear? Next, in a spark ignition engine, the increase of compression ratio will. Spark ignition means petrol engine, and in petrol engine, any increase in temperature or compression ratio will definitely increase the knocking tendency. If you increase the temperature, if you increase the compression ratio, it is definitely going to increase the knocking in petrol engine. If you increase the temperature and compression ratio in diesel engine, for diesel engine this is going to decrease the knocking, but for petrol engine it is going to increase the knocking. The parameter to be kept constant during the Morse test. Last question, my dear students. When you conduct the Morse test, then what parameter remains constant? So Morse test is basically done for multi-cylinder engine. It is done for multi-cylinder engine, and it is done for what purpose? It is done to find the indicated power, then friction power, and then mechanical efficiency of a multi-cylinder engine. And while doing this Morse test, the speed of the engine is kept constant. Okay. Do not forget to subscribe our YouTube channel if you have not done yet, and also please do not forget to like and share the session. And I want to wish all of you happy Independence Day in advance to all of you. And the real meaning of, this is something which we used to celebrate Independence Day. I think when we were in our school, the meaning of Independence Day was different. That is, we need to get, we need to go to the school. We need to basically, there were some cultural festivals. Cultural, what kind of cultural sports and things that happens in the school, and you also get some sweets, right? When you are in the college, then the meaning of Independence Day is that you get a leave from college. You don't have to go to the college because it's off. When you are in a job, then also the same thing. But the real meaning of independence is that you need to understand the value, how we got the independence, and how it is so much important for any country to be independent, okay, not under someone else's rule, right? And also in how as a student you can get to understand the meaning of independence is to become self-dependent also, and to get a job so that you can do something for your country, right? And you can make it more, somehow contribute in the growth of the country. Okay, so happy Independence Day to all of you in advance. And now I'm going to see you on Monday. So I am going to see you on Monday, next class of mine. Okay, so my next class will be on Monday. See you on Monday. Thank you so much. I'm not sure about tomorrow. I don't think that tomorrow there will be any class. Okay, Prisma, but I will see you on Monday. Thank you so much. Have a nice day. I think Surya sir will take class on, will be taking class on Friday. But tomorrow I am not sure where there will be any class. Okay. Thank you so much. Have a nice day. See you on Monday. Thank you so much. Have a nice day.